Hey everyone, so we're going into lesson 1 of unit 3. We're going to look at rational expressions and equations this unit. Really not so much functions. I probably should change the title, but examples of rational expressions when you think rational numbers. Hopefully you're able to classify those by now. It is a fraction. So rational expressions are going to have polynomials in the denominator, so some sort of variable in the denominator of a fraction. So something like this. All right, so you might make a note, variable in the denominator. So we have to watch for values of x or whatever variable you're using that make the denominator equal 0. All right. And those are what we call restricted values. So for example, we have x minus 2 over x plus 9. All right, well, if we look at this denominator, because we can't have 0 here, and think about why that is. X minus 2 divided by 0 would equal what? All right, this is undefined, no solution, and so we want to avoid that. So if x plus 9 is equal to 0, then x, or cannot equal 0 rather, then x cannot equal negative 9. Well, this is what we call a domain restriction. So when talking about the domain of this rational expression, we think about all of the x values, and this is going from negative infinity to positive infinity. Well, right at negative 9, there exists an open circle where this value cannot be. Right? It is undefined at that point. It can be any other number, though. You plug anything else in, and you'll get, it might not be a very pretty number, but you'll get an answer. And so the domain for this, and we're going to describe our intervals here. We're going from negative infinity all the way to negative 9. We're not including that, so we're putting parentheses. Union, and we pick back up on the other side of negative 9, and then approach infinity. All parentheses all the way across. Okay, and so that is your domain. And we can do that for any rational expression, and we need to do that for any rational expression. It's identify those restricted values before we simplify it. So for example, this one, you have 5y squared plus 10y. Well, I need to factor that out to find all of my restrictions. So you think about when we set something equal to 0, this is like solve from lesson 4 of unit 2. So U2L4. All right, doing those same skills here. So this factors out of 5y, and we're left with y plus 2. Well, fractions would tell us to go ahead and reduce this, which is fine. But before you reduce it, you have to find your restrictions. So 5y equals 0, y cannot equal 0, and y plus 2 is not equal to 0, so y cannot equal negative 2. Those are your restrictions. And you can see we have to do that because then these cancel out and we end up with 1 over 5y. All right, so those same restrictions don't exist in this one right here. It's just 0. All right, that's important because our domain has this restriction on it. And so for this particular one, at negative 2 and 0 both, there's an open circle. And everything else can be included. And so when we're writing our domain, we're going to describe each of these intervals in turn. and take the union of them. So we're going from negative infinity to negative 2, negative 2 to 0, and then 0 to infinity. You should always have one more domain interval than you do restrictions. So if you have 2 restrictions, you'll have 3 intervals, and that will always hold that pattern. Okay, so always find restrictions before you reduce. But you still want to go ahead and reduce that. Okay. So I'm going to leave this one for you to go ahead and pause the video and try on your own. Okay, so if you look, you can see kind of what I did here. I skipped a few steps. So these are set equal to 0, and I just solved them kind of in my head here. All right, so double check your answer with that. Okay, so you find the domain, you can also evaluate a function. And so for this one, 3x minus 1 over x plus 2x minus 2. I'm going to go ahead and factor that. This is in function notation, so this is a rational function. So x cannot equal. Your restrictions are both 2 and negative 2. Or you can write this as plus minus 2. Okay. So when we are evaluating, we need to take into consideration our restrictions. And so for r of 3, you're just going to plug in 3. This didn't simplify, so I'm just plugging it in for each x, and you could do that here. And solving that out, you'll get 9 minus 1 is 8. 9 minus 4 is 5 8/5. And we do that for each one. So negative 1, we plug in as well. 3 times negative 1 minus 1 over negative 1 squared, which is 1 minus 4. So we get negative 4 over negative 3, which reduces to 4 over 3. And then we get to this last one, and it asks for r of 2. Okay. Well, this results in no solution. Tell me why. Okay, so hopefully you notice that this is a restriction, which is a value that x is not able to be. If you plugged it in, if you went ahead and plugged it in, you would get 0 in the denominator, and then hopefully you realize that that is also no solution. Okay, so we're going to go through some operations with our rational expressions. So before we go into adding, subtracting, and multiplying and dividing them, let's look at just simplifying them. So you're going to follow this step by step. So factor everything. If it factors, factor it. Cancel out common factors, and this is like 1 on the top and 1 on the bottom. I want to highlight this real quick. We can only cancel factors, cannot cancel terms. All right, so know the difference between a factor and a term, and then write your solution. So for example, we have a minus b over 2b minus a, or 2a, excuse me. I see two things here. I have an a minus b, and I have a b minus a. So on the bottom, I'm actually going to factor out a negative 2 to get those tops to match. So a minus b over, and I'm going to pull out its negative 2, and then this will become a minus b. All right, so think about both of these signs would switch, and now the 2 is gone. All right, so these cancel out. So I end up with negative 1/2 as my final answer. here again, factor out everything. So I'm going to bring out first the 2, then I'm left with 2x squared minus 5x minus 3. And then that breaks down. This is a 2. So I have to have a 2x and an x. This is a 3. So I have to have a 3 and a 1. This is a 5. Well, 2 times 3 is 6. So I want to do 3 times 2. That's 6. And 1 is 5. If the 6 is negative, then that one's factored. Then I do the same thing with the bottom. So I have 2x squared plus 11x plus 5. Well, 2 and 5 are primes, and 2 times 5 is 10, which gets me really close to 11. So I'm going to do 2x and 1, and then x and 5, because that's 10, 11 x's. And another way to kind of expedite the factoring process is the fact that I already had a 2x plus 1 on the top. Something's going to match when the whole point of this is to reduce them. Okay? Your restricted values are -1/2 and -5. Be cognizant of that. Sometimes I won't ask you to list them, but it's just good practice too. Anything divided by itself cancels out. So 2 times x minus 3, or 2x minus 6 if you want to redistribute, goes to the top, and x plus 5 is on the bottom. All right, that leads us into multiplying, because it's really just a fancy simplification problem. We just have fractions listed next to each other. We're still going to factor all tops and all bottoms, multiply it, or just write it as one fraction and then cancel common fractions. So in other words, you can write this as AC over BD, right? Write it all as one fraction, and that's fine. Recall that for division problems, those are multiplication problems. We just need to flip the second one and multiply. And then we can rewrite that as 1 as well. All right, so keep, change, flip, or keep, flip, change, or however you want to remember that we're multiplying by the reciprocal of the second one. All right, so that being said, if we have -wy squared to the third, and this is going to be a lot like Unit 1, actually. So why don't you go ahead and pause your video and work this one out. Okay, so hopefully you made some progress. I wanted to pick up right here. So hopefully you can see I distributed my exponents. That's all I did. And then I crossed out things that were exactly the same on the top and bottom. But we can further this by saying, okay, here's a w here. So this cancels one of those. Here is 4 y's, right? So all 4 of these cancel 4 of these. And then that is it. So at the top, we're left with -w squared. And then we have y to the 4th. And at the bottom, we're left with 3. And so lots of different ways to do that as far as canceling. Just remember your rules of exponents. So that's real similar to last unit, lesson 1. For these, we're going to always factor first. Okay, after we get this problem set up, before we try to like multiply anything. Okay, so the first thing I'm going to do is flip my second fraction and just rewrite this. So we have 2x squared plus 7x minus 15 over 4x squared minus 100 times 2x squared minus 9x minus 5 over 4x squared minus 1. Now, keep in mind, this means the same thing. We would flip this up and multiply. Okay. All right, so now we factor everything. So this one factors as 2x minus 3 and x plus 5. You can double check me on that if you need to. This one, I'm actually going to factor out the 4. So if I factor out the 4, I'm left with x squared minus 25, which is a difference of squares. and that factors as x plus 5 and x minus 5. Now, as you're factoring these, again, keep in mind that a lot of times top and bottom will have matching things, both diagonally and straight up and down. So if you get stuck factoring, look at some of the factors you already have and see if that will help you. So for example, the bottom here factors as a difference of squares. So we have 2x minus 1 and 2x plus 1. We've not had any of those anywhere else. So odds are that we're going to have a 2x and a 1 in the top. Well, that means that we also need an x and a 5 because it multiplies to 5. It adds to negative 9, so my bigger number is negative, my smaller number is positive, and now that's factored. And so a little bit of logic goes a long way when you're doing these. Now, in these types of problems, I won't ask you to list your restrictions. That's just one more thing in already a long process. What you are going to do now, though, is look at the top and look at the bottom and cancel any factor that is the same. So I have an x plus 5 that cancels my x plus 5. I have a 2x plus 1 and a 2x plus 1. So those went up and down. Diagonally, I have an x minus 5 on top and an x minus 5 on bottom. And that's the only things left that matter. I can't cancel these two x's. They are terms, not factors. So 2x minus 3 remains on top, while 4 times 2x minus 1 is left on bottom. And that is your final answer. Go ahead and pause the video and try this one. Okay, so here we are in factored form. Go ahead and double check all your factors. We're going to cross out the x plus 1s, diagonally the 2x plus 5s. Here over here we have vertically 2x plus 5s, and then we also have 3x plus 4s. Everything is canceled. That does not go to 0, it goes to 1. Okay, so that is multiplying and dividing. Granted, we had more divide examples. Those have that one extra step. Other than that, it is a multiplication problem. Adding and subtracting is different, and you need to be really efficient and meticulous with your work when you are adding and subtracting. Keep in mind that we need common denominators when we add and subtract. So 3/4 plus 1/6. I could multiply this one by 6 and this one by 4, getting those to have a common denominator, then adding them together and reducing. However, if I recognize the fact that they both go into 12, I could use 3 and 2 and get that reduced answer right away. So 3/4 way 2 is faster and thus more efficient. All right, so factor all the tops and all the bottoms. Use exponents for repeating terms. All right, so write them out twice. Like write out like x plus 3 squared if you need to. Okay. Cancel within each fraction, so reduce fractions. If they do, don't reduce diagonally because we have addition or subtraction. Find your least common denominator or your least common multiple of your denominator. We'll talk about how to do this. And then build up each fraction so it has the least common denominator. Add, subtract. Make sure you use parentheses with subtraction so you don't mess up a sign. Always reduce your answers to the lowest term, but if you've done this along the way, then you won't need to do it at the end. So here's our first example. X plus 1 over 6 minus 2x minus 3 over 4. All right. Neither one of these reduces. They don't have anything in common. So I know that both 6 and 4 go into 12. This was just like the example above. So I'm going to multiply this by 2 and this by 2, putting parentheses around the fact that that will be a binomial. Then on this side, same thing. I'm going to multiply by 3 and by 3. When I distribute this 3 through, I'm going to distribute it with the negative. All right. So what I'm doing is I'm getting that common denominator of 12. I only need one fraction at this point because it's going to be 12. So I distribute my 2 through, and I have 2x plus 2. And then I distribute my negative 3. So I have minus 6x plus 9. All of that it will be now over 12, finding that common denominator. Combining like terms is last, so I get negative 4x plus 11 over 12. Nothing has anything in common. Well, 4 and 12 do, but they all have to have the same thing in common. So I can't reduce, and I'm done. All right, so if they already have a common denominator, you can just go ahead and combine like terms. Go ahead and pause the video and try this. Okay, so if you just combine like terms across the top, then you end up with this. The problem is we have never factored the bottom, and we want to make sure this is in lowest terms. So I can rewrite this as x plus 3 over x plus 3 and x minus 3 using my difference of squares factoring. Well, x plus 3 and x plus 3 are the same factors, so those would cancel. And my final answer is actually 1 over x minus 3. And I know I'm going super fast, so feel free to rewatch any of this if you need to. Adding and subtracting can be the harder ones. When you're looking for a common denominator, and the question in the steps says how, right? The first thing you're going to do is factor everything. So this is x plus 1, x minus 1, difference of squares. This is x times x plus 1, taking out that GCF. All right, so my least common denominator is actually going to be a list of every different factor that I have. So I have an x, I have an x plus 1 right here. This one has that x plus 1 already, and it has an x minus 1. So I need all three of these factors to be in my denominator. So I'm going to multiply each fraction by what it's missing. So this side is missing an x. This side is missing an x minus 1. And so by doing this, I am giving them the same three terms on the bottom. And so x times 1 is x plus 2, and this is going to distribute through, 2x minus 2 is now over your x plus 1 and your x minus 1, which is your LCD. All right, so last I just need to combine like terms here, so I get 3x minus 2. That doesn't factor. And so my LCD is just going to come back down here to the bottom. There's no need to remultiply that. I'm finished. Okay. All right, couple more that I just want to point out here. Notice that if it has similar denominators, but not quite the same, then we can factor out. If we just need to flip this, we can factor out a negative. All right, so we have 5 over a minus 2 minus 3 over negative 1 times a minus 2. Factoring out that negative will flip these around. All right, so minus a negative becomes plus. And we have 5 over a minus 2 plus 3 over a minus 2. Now we have common denominators. 8 over a minus 2. That does not reduce. Do not reduce your 8 with your 2. That is your final answer. So just keep in mind that negative 1/2 is the same as 1 over negative 2 is the same as negative 1 over 2. We can kind of move this negative sign out of the bottom and put it wherever we want. All right, and that is it for this video. I know that there are some other examples that you might come across that might be a little more challenging, but just ask as you run into questions, all right? Have a great night.